Okay, so all of this that we've looked at so far, integration and things, is used to find areas enclosed by curves. And there's two ways they can be enclosed by the curve. They can be enclosed by the x-axis or by the y-axis. And we're going to look at the x-axis today. But the thing you need to keep in mind is that when we work out an integral, we're putting in positives and negatives and things like that. And the answer is going to take that into account. It's going to give you, as you can see in this first case, this is going to give you a positive area, and because it's above the x-axis. But when you put in integral for this second one, you're going to get a negative answer, okay, which you'll need to take into account. In this third case, we have some of it below and some of it above. So this one's going to be mixed, and it depends on where your endpoints are, whether you're going to get a positive or negative answer. But you've got to keep in mind that area is positive. We can't have a negative area. So mathematically, when we're working on a function, I can tell you it's negative. That just tells me it's below the axis. It doesn't have any impact on how large the area is, okay? So when you're asked to find the area of a region, I want you to first draw it, because if you don't draw it, you're not considering whether there are positive or negative answers, and you can miss some really important information. So you need to draw a sketch first, and I want you to show the really important things like the intercepts and intersections, because on the more complicated ones, they're not going to tell you where to start and finish. You're going to have to figure that out. So you need to work out those intercepts or intersections of the curves. Okay, then you're going to determine either one integral. So in the first and the second example of those pictures, they're just one integral. You've got one function, and it's either all positive or all negative, and you substitute it in, and you're going to get an answer. But in that third one, the mixed one, you are going to have to work out the part below the axis, because it's going to give you a negative. And then you're going to have to work out the part above the axis, because that's going to give it a positive. And if you add a positive and negative, you're going to get a smaller answer, but that's not going to be the total area. You need to do them separately. So there's going to be two integrals for that one. So determine the integral or integrals, evaluate those, and then give your conclusion. Okay, and remembering that because it's area, it's square units, and that's how you need to give your answer. So have a look at this first example. Then what the area bounded by y equals 4 minus x squared and the x-axis. So we've looked at that before. 4 minus x squared. Well, that's going to give you a parabola. It's upside down. It's going through the point 4. The intercepts that you're looking for are going to be 2 and negative 2. Remembering all we're doing is factorising 2 plus x, 2 minus x, and working out the intercepts. And we want the area bounded by that curve in the x-axis. So we're looking for this area in here. So in this case, it's very simple, because all of the areas above the axis, it's going to give me a positive answer. Area is positive. It's just a straight integration. So this one's not too bad. But the information that's not in the question are these endpoints, your boundaries. So you needed to work those out before you can answer this question. So to find the area, what you need to do is find the integral from negative 2 to 2 of 4 minus x squared dx. Okay, so when you integrate that, what do you get? Well, you get 4x minus third x cubed, and that goes from negative 2 to 2. And then you're going to start substituting. So you're going to get 8, so 4 times 2, minus a third of 2 cubed. So that's going to give you a third of 8, so 8 over 3. And then we are going to subtract. So if you put in negative 2, you're going to get negative 8. And then you're going to get plus 8 over 3. Now, really important that you take this step by step, because there's lots of negatives. Things cancel each other out when they're supposed to, or sometimes people will cancel them out thinking that they do when they shouldn't have. So please don't rush it. Don't skip steps. Take your time to do it properly. So when you plug all that in, you get 10 and 2/3. So what is the area? Answer the question asked. Okay? So the area is 10 and 2 over 3 square units. So let's have a look at another example. Now we've got the area of the region bounded by y equals x squared minus 1 and the x-axis. So what kind of shape is that one going to be? Hopefully by now you're able to say, hey, that's a parabola. That's really simple. Goes through minus 1. The intercepts here, when you factorize it, give you 1 and negative 1. And in this case, it's this area below the axis. So what's that going to mean for my integral? So we're going from negative 1 to 1 of x squared minus 1 dx. Well, that's going to be the integral of x squared is x cubed over 3. It's minus x, and it's from 1 to minus 1. So when you substitute in, you end up with 1 cubed over 3, so a third minus 1, minus, and put in your negative 1, you get negative a third, and plus 1. And so all up, my answer is negative 1 and a third. But that's not the area, is it? Okay, so therefore the area equals 1 and a third units squared. You can write out square units, whichever. Now I want you to pause the recording, draw number 3, try and work it out, and then come back and see how you go. Alright? So, when we draw this, what do we get? Well, x cubed looks like this. It goes through the origin. We want it between the lines x is equal to negative 2. So that's that part there. And x is equal to 3. So that would be this section over here. So you can see we've got this negative area down here and we've got this positive area over here. So I can't just type in one simple integral, because if I do that, some of the positive and the negative will cancel each other out and my answer is not going to be correct. Alright, so give them a name. Make sure that the examiner knows exactly what it is you are working out. Okay, so I'm going to call them area 1 and area 2. You can call them anything you like. And then work them out separately. So area 1, well, that goes from negative 2 to 0 of x cubed dx. Well, if I integrate x cubed, I end up with x4 over 4. And that's from negative 2 to 0. Which is pretty easy to substitute into. We end up with 0 minus, and then negative 2 to the power of 4 over 4 is 4. So this is equal to negative 4. And then, when I do the second part, well, I'm starting at 0 now, and I'm going to 3. Same integral. It's just the substitution that you've got to get right. Yeah? So you get x to the power of 4 over 4, and we're going from 0 to 3. So same thing that we're substituting into, but this case, when you put in your 3, you're going to end up with 81 over 4. You put in your 0, let's take away 0. So this is equal to 81 over 4. So if you had worked this out as just one integral from negative 2 to 3, you would get negative 4 plus the 81 over 4, and your answer would be incorrect. Okay, so you need to be able to then look at that and say, well, the area that we need is 4 square units plus 81 over 4 square units, and that is equal to, and if you want it as a decimal, you can, as a fraction, you can, doesn't matter. If you'd done it the other way, your answer would only be 16.25, and that's not right. So this is why you need to draw your sketch. So that's what you need to be able to do exercise 3.6, but be careful. I want you to do the first 7, and then I want you to do from question 14. I want you to leave out 8 to 13. We're going to do them separately. Good luck. I'll see you in class.